In this video, we're going to graph a hyperbola not centered at the origin from an equation in standard form. First thing I want to look at, this is the correct graph. And so we already have the answer, but I'm just going to show how you get there by finding, it says graph the hyperbola given below using the transverse axis. We're going to find the transverse axis, the center, the vertices, and the co-vertices, and then we're going to show where those are plotted on this graph. Now, if you didn't know the graph was there, how would you figure out what the graph looked like? Well, you'd look at the y value being the first term, and then the x value, and that tells us that this thing's going to open up and down, which means our asymptotes would be y equals plus and minus a divided by b x, and that our center, we always know our center is going to equal h comma k. Our vertices and our foci. So our vertices, we know this is the center. So they are moving up and down. So the y values are changing. The x values are staying the same. So our vertices, how we'd find those, remember the distance between the center and the vertice is always a. So we would have h would be our constant there, and then we'd have k plus minus k plus minus a to find the vertice, and we'd have the same thing to find the foci, except instead of saying plus minus a, we'd say plus minus c. Now to find the co-vertices, these are actually found at this spot and this spot, so the x value is changing there. So we would have h plus minus b, and then k would stay constant. Now that we have all that information, we can start filling this out and say that a squared is equal to 4. So a is equal to plus and minus 2. And b squared is equal to, this would be over 1. So b squared is equal to 1. So b is equal to plus and minus 1. So we can say that h, if we go back and get our center h would be the opposite side of this, because it's always open. This is not h, this is k. So it's still the opposite sign though. So we have negative 1 here. And then this would be negative 3 for h. So we would have the vertice being negative 3, comma, negative 1 plus minus a, which is 2. We'd have negative 3, comma, negative 1 for k, plus minus c, which I don't know c yet. I can find c though by saying that, I'm just going to write it here. C squared is equal to a squared plus b squared. A squared and b squared would be 4 and 1. So c is equal to root 5. So I'd have negative 1 plus and minus root 5 for c. That's how I'd find the foci. The co-vertices then would be h, which is negative 3, plus and minus b, which is 1, comma, k, which is negative 1. So we could split these and write that this is negative 3 plus 1, which would be negative 2, negative 1 for one coordinate, and the other one would be negative 3 minus 1, which is negative 4, negative 1 for the other coordinate for the co-vertices. This would be negative 3, and then negative 1 plus 2 is 1, and then negative 3, negative 1 minus 2 is negative 3. And then finally, we can say that our asymptotes would be plus and minus a, which is 2, divided by b. So we have 2 over 1x. Now we can plot some of this stuff. So negative 3, 1 would be 1, 2, 3. Negative 3, 1's right here. Negative 3, 3. Or negative 3 would be right here for the vertices. I'm not going to plot the foci, but we know the equation to get them, or know the coordinates to get it. We have co-vertices, which is negative 2, negative 1. So negative 2, negative 1 is right there. Negative 4, negative 1 would be right here. And then if I plot this plus and minus 2x, I'd get asymptotes that run like this.